Okay. Good morning. Today is our last lecture for the things to be covered in the midterm exam. Okay. And after today, we will start 2 lectures on our course survey presentation. Okay. That means TA selected around 8 survey papers. That means 8 groups. And I think the first group TA already informed. It will be Thursday. Yeah, just make sure you do good preparation. Okay. The next lecture, we will still have the regular sign-up sheets. That means everybody's still required to attend. It doesn't mean it's not covered in the midterm. You will not need to attend the course. Okay. And then after that, we'll have midterm exam. After midterm exam, if you read it carefully, after midterm exam, the May 3rd lecture will have no class because we will move the class to the May 5th. Okay. May 5th, we will have 2 sessions. And then May 9th, we have, I think, total 4 sessions. So make sure if you plan to present, you must be there for sure. I hope everybody can be there. And we still have the registration, the attendance sheet. The attendance sheet, like I said, we require everyone attend half of them. Okay. So later I will discuss with TA to see how we should partition the student grading. That simply says for peer grading, you need a grade, you should attend half of them. You will be assigned to particular projects to grade. I will discuss with TA how we implement this one in a nice way. Okay. But anyway, make sure you prepare some. I know there are some people, they have final exams. They may have some conflicting schedules. If you have something like for certain sessions, because you are attending the final exam or some other thing you could not attend, you should probably drop me or TA an email, say which session you definitely cannot attend. Then when we sign the attendance sheet and also sign your grading, we try to avoid those conflicts. That simply says if you have quite a few midterm final exams, we try to make a proper arrangement. Okay. So then we come down to the very last lecture. This lecture is a little new, but I try to finish in 1 hour. Okay, to make sure you get all the things you need to expose. Then we finish the lecture. Okay. This one is on advanced pattern-based classification. Okay. I assume everybody in the class knows classification. Okay, but later I should get the statistics of how much you know. Okay. This one, anybody can guess what it is? This one actually is a Zion National Park. It's around a little south of Salt Lake City, north of Grand Canyon. Okay, so that area. That area, they get quite a few good national parks. Okay. So I will first give you a little basic concepts of classification. I probably should get a little statistics. How many people basically have knowledge on classification? Okay, seems almost everyone. How many people almost have no knowledge on classification? Seems nobody. Okay, so I assume you have the basic concepts of classification. Otherwise, you will have a hard time to digest what we discussed. Okay. Classification, if you study Introduction to AI, study machine learning, study data mining, almost for sure you are going to get this key concept of classification. The classification has been very, very popular used in data analysis. Okay. The general philosophy is you have some training examples. For example, you get some tissue, then they can label, say, this tissue is cancerous, this tissue is benign. Okay. Then you try to find what kind of characteristics you can describe and can distinguish the cancerous from the benign one. Okay. So this is training instance, means you give a set of labels for the training data. Then you try to construct models. The model essentially, it could be a set of rules, it could be a neural network, it could be a support vector machine, some kind of complicated mathematical model, could be decision trees. There are many things, right? So this is, a classification model. Once you construct this prediction model, you can have some new test cases. For example, people can give you a set of new tissues, say which one is cancerous. Okay, so that time you may say it's positive, means cancerous, it's negative, means it's not. Okay, so that's very useful. Okay, for example, if you're thinking about you give loans to some people want to buy a house, whether you want to give the loan. Okay, then the same thing you will say based on the income, based on all the status. You may build up a model. Then you will say whether, for your particular, person who try to borrow money, you will say whether I give you a loan or do not give you a loan, right? So that's a very typically used cases. Classification, there are many, many ways to do it. Okay, just to give you a simple example, the most easiest one could be decision trees. You just construct a tree. At a certain time, you branch out. Okay, and another one called support vector machine. If anybody study data mining or machine learning, you probably know support vector machine. Try to find the maximum margin to separate the positive and negative cases. Okay, and you may build up a Bayesian networks. Based on potential factor you can imagine, you can draw those topological graphs. Some people call this is a probabilistic graphic model. Okay. And you also can construct neural networks. The recent quite hot study on deep learning actually is based on some kind of neural network model. Of course, we will not get into details, but there are many, many classification methods. Okay. And the classification method has many, many applications. That's why it's so popularly studied. For example, you can do text categorization, you can do face recognition, you can do drug design, you can do spam detection. There are many, many tasks, thousands of them, right? That's also why even you study statistics, you go to general engineering or some places, you also will study classification methods. Okay. But here we are not going to introduce so many different classification methods. That should be a full course, right? But we are going to just introduce one interesting one called pattern-based classification. Essentially, is you study the data sets, you try to work out the patterns, and you use pattern to describe your model. Okay. And for this classification, why I really want to use this last class to explain this, to introduce this, is recently our group got a very interesting method called DP class by one PhD student, Jingbo Shang. I really want to introduce this one to you, that you may even like to use it. Okay. So I first give you a little idea on what is pattern-based classification. The pattern-based classification means you try to do some kind of pattern mining, like a frequent pattern mining. Okay. Then you work out this pattern. You can see how they are tightly associated with your positive class and negative class. Okay. Then you can use this pattern to explain, to model your whole classification, predictive model. Okay. What's the benefit of this? Okay. The pattern is much easier for people to understand, rather than if I give you a neural network or give you a supervac machine, you probably look at those formulas. You say, I can only treat this one as a magic box, a black box. You say, trust me, I'll give you some good results. Okay? But the problem is none of the classification model you treat as a magic box or black box will give you 100% accuracy. That means if you try to diagnose this person as cancer or not, okay, you take this magic box, you say this one is cancerous or not, nobody can guarantee it's 100% accurate. Okay? That leaves human a lot of burden. You're just thinking, suppose you were a medical doctor, okay? A patient came, and you run supervac machine, you got one. But the supervac machine said, this person has cancer. Okay? You believe it or not. Okay? But the doctor has lots of experience. Okay? You think about it, a doctor may work on this cancer diagnosis for, say, 20, 30 years. If you just treated your machine as a magic box, a black box, the doctor will be very reluctant to use it because he may think I actually is a better judge than this black box. Right? So you need certain explanation why you say this person is cancerous. Okay? But they cannot give you. They give you a very complicated mathematical formula. Okay? So this pattern-based classification has a nice way to communicate with human. You think about it. If I give you, say, because this person got this condition, under this condition, not the other condition, this person, I think he has cancer. Okay, so that's probably much more convincing for medical doctors rather than you give them a very complicated mathematical function, right? So that's the particular nice thing if you can get similar accuracy, but you can explain it. That's why pattern-based is useful. For example, okay, you just think about it. People give you something. Sometimes you need to combine the feature. You can easily explain it. For example, if I give you one, say, apple, you even do not know apple means what because there are so many different ambiguity, right? But if I combine the features, I say this is the apple pie. So you will say I order it. I expect to pay, say, $5. But if you say this is the Apple iPhone, $5 you will get a junk, right? Like a broken one, right? Likely you probably have to pay $500. So that's actually, it's a one you can see. You need features. You need to combine the feature to get a feature construction. For example, you think about if you have some chemical compounds. If you can say these several chemical compounds or these several chemicals structured in this way, likely you will have certain function. So you probably can see the pattern is I make several components, combine them together. I may explain things better. Okay. So that's the philosophy. You probably can see, just give you an example for pattern-based. Suppose you are analyzing some chemical compound. You may say this drug is inactive, this one is active, this one inactive. So you want to find what kind of thing may lead this drug active. Okay. Then you may, if you compare them, you may say, oh, if this kind of structure is inactive, the other structure is active. So you will have much better explanation. That's the reason the pattern becomes quite useful. Then pattern-based classification has been studied by many people. I give you a bunch of these things, but I do not expect that you will read all of them because we are not going to discuss these in detail. The only one I really want you to read, for example, for our midterm exam, is the very last one. I'm going to show you the very last one, but I will go it step by step by the history and the differences. Okay. Actually, the first pattern-based classification methods was proposed by Bing Liu, who actually came here to give a talk. He's a professor in University of Illinois, Chicago. Okay. At that time, he was in Singapore. He got a one called classification based on or by associations. You call the method classification by association. That's why I call it CBA. He basically worked out a bunch of classification rules. The left-hand side is a condition. The right-hand side is class label. That means this condition implies cancerous. This condition implies benign. Okay, so people can see if you can work out such rules using pattern mining, okay, then you will get something you can hand in to doctors. The doctor probably will buy it. Okay. And there are quite a few others, including ourselves, get a lot of methods, but I'm not going to introduce them or not introduce them at all. I will directly jump to the very last one, but this is not the very, very last one. This one was published in 2007. The one I'm going to introduce you is published in 2016. Okay. So let's skip a bunch of things. I just give you something very quick. Otherwise, we just cannot finish the course. You can see the Ming-Liu's method basically saying you get a bunch of conditions. It implies this class label, this attribute is with a certain class, C. That means you can think this one is cancerous. Okay. Then you say, under these conditions, these are the patterns. It implies this class label is cancerous. Then you get a certain confidence, certain support. Of course, the higher confidence, you better present it to doctors. But it's very low confidence. You probably don't want to present it because you say there are about a 51% chance it has cancer. Probably you don't want to show it. But if you say this rule is 90%, true, you want to show it. Another one is support. It means how many cases in your data to support this. Okay, the frequency, you can say. Of course, the more support, you feel more comfortable. Okay, that means you have more patients like this. They have cancer. You show it to the doctor, say, this one likely is cancerous. You feel much more confident because you have a large support. Right? So he, based on this, he worked out a classification model. He even compared with some very competitive ones, like Ross Quinlan worked out a C4.5. It's a decision tree-based classification. He uses this, association rule mining, and he can actually beat C4.5, a typical classification tree method. So that paper has been cited very frequently. In 2016, this paper actually got one of the highest impact paper award in KDD conference. Okay, that means after almost 20 years, people really realize this one is an important paper. Okay. Then there are other methods, including this one actually developed by ourselves. Okay. But I'm not going to introduce them. This is just another picture of the Zion National Park. Okay. Now I'm going to give a little theoretical analysis. That means why this frequent discriminant pattern will have the power to do classification. Okay. This one was done by Hong Chang. She published this paper in 2007. Now she's an associate professor in Chinese University in Hong Kong. Okay. And her thesis actually get a KDD dissertation award. I think it's honorable mentioning, like a number 3 in the whole pie. Okay. Then I should give you the general philosophy. The philosophy is this. Okay. She did a little detailed study on why the pattern is useful. Okay. The first study is she took a lot of data from machine learning repository. The training data is you have you have sonar data. The sonar data may have the label, positive and negative. You have lots of data. Okay. And she based on this to study how many single attributes will have information gain, how many combined attributes will have information gain. And she found She actually showed many such data in machine learning repository. She just using Ross-Quinlan, that information gain, the information theory. She found a very interesting fact is this. If the pattern length is 1, that means a single pattern. It's more like an apple. Okay, you say apple is, then you decide whether it's model. And the other one could be apple pie or apple iPhone or something like this. Then you see single length, the information gain is very much scattered. You can see some, of course, gain is high. A lot of gain is not so high. But even they have gain, they are very scattered, very sparse. Simply says the chance you can capture a lot of gains using length 1 pattern is very scarce. That means if you just use single feature, you try to do classifier, no matter how nice you are, or how smart you are, because the gain is already very sparse. So you try to capture those gains, the chance is not that high. But then she found if you combine the patterns, that means length 2, length 3, length 4, you can see all these data sets. When you start combining, you say, now I'm using length 2, length 3, length 4. Immediately, this gain shoots up. That means you use a single feature, try to cut it. Actually, the decision tree is every time you take one feature, try to split. And you take another feature, try to split. But if you use 2 features combined, you think, especially, to give you a simple example, is exclusive OR, the gate. Then you use a single feature, try to divide them. It's hopeless. But if you use 2, okay, you have power because of the 2, the information gain is higher. So you can see 2, 3, 4, 5, these information gain are not bad. You will be able to capture something. But if you use 2 long lengths, like length 10, length 12, like those ones, the information start dropping. The gains start dropping. That means you use a very long pattern, does not help you. Okay, that's just based on information gain. She studied many data sets. In machine learning repository, she found actually it's almost universally true. Okay, you get a longer pattern, you have more benefit. Okay. But why a lot of people do not use it? Just because, remember, you use 1, you already get lots. You combine them together, you get almost cross product. The number explodes. Okay. So the pattern mining will help you to reduce the number. Why? You look at this. Okay. She studied another interesting is based on the frequency. And she draw the information gain, all these. Okay. Another interesting thing you can watch is this. If the support frequency is very low, like here, like only happen once or twice or something, the gain actually is low as well. Okay. But once you start increasing the frequency, the gain started jumping up. Okay. That means if you want to capture good pattern to do classification, you need a certain frequency. It's too rare, only happen once or twice, it's hard to make it very useful. But once you start beefing up, have certain reasonably frequent one, the gains start jumping up. She actually not only studied information gain, she used other measures typically used in classification, like a Fisher score. She got almost exactly the same kind of change. Then she basically say, if you want to do classification, no matter what method you are using, you need to find a frequent and discriminant patterns. Pattern means you need length a little longer, not length 1, but a length 2, 3, 4. Okay. That's why she says, if we do this frequent discriminant pattern mining, we are going to win. Okay. Based on this, she actually did a frequent discriminant pattern mining. You can see using frequent pattern. She tried, these are all machine learning repository at UC Irvine. She tried this almost like 20 different data sets. She used support vector machine, including RBF kernel, which is very popularly used. She also used the C4.5 decision tree method. Okay. Then you see the interesting thing is she used her frequent discriminant pattern. She found that using frequent discriminant pattern, her classification accuracy is almost always the best. Okay. That means the frequent discriminant pattern can compete with decision tree method, can compete with SVM, very powerful classification method. Then what is a disadvantage? The disadvantage is you need to mine a lot of patterns. How much you need? Here, this mining is, you get hundreds of thousands patterns. Okay. Then you can do good classification. And you probably can see, she actually shows how many patterns you are going to get. Okay. Like, she actually shows if you set a minimum support, and she was using this pattern-based method, and you can see you need you take a minimum support as 2,000, you get 68,000 patterns. So that's a large number of patterns for any human being to digest. That means if you get a doctor want to check this tissue, you give him 68,000 rules. You think they're going to be pleased. They say, it's better let me do it by myself, right? Rather than you give me that many rules, I try to apply or try to comprehend. Obviously, this is, you get 100 rules, probably they are going to do it. And she basically showed even you raise up to support 3,000, you get 100 rules or something, you still get a reasonably good accuracy. You probably can see here. But that means you do get a very good result, but on the other hand, you need to suffer a lot of rules and also the efficiency. Okay. Then the second year, she developed another method called direct mining of discriminant patterns. And she shows instead of first mine pattern do classification, she was constructing the tree and prune the tree, directly get discriminant pattern. She shows she can do far better. Okay, I'm not skipping this. I just show you how far better she can get it done. You can see that's her original algorithm. This is the number of seconds she was running. And by taking her discriminant frequent pattern mining, she can lower down that much. Simply says you can see there's order of magnitude or 2 order of magnitude reduction on the running time. Okay, but it still keep very close accuracy. Okay, but this one still have a problem is you still get a reasonably big set. How big it is? It's probably in the order of 1,000. You get 1,000 rules or hundreds of rules. You give it to doctors, the doctor may still not be so pleased, right? So that's 2008. Okay, you probably can see the running time is substantially smaller. The accuracy actually is quite comparable. Now we go down to the very last one I'm going to introduce you, called DP class. Okay, this one was done by one of our PhD students called Jingbo Shang. Okay, he is really, really great in at thinking and also of course at coding. She actually, when she was undergrad, she was leading one university team to the ICPC programming context. That university is almost always get into top 5 internationally. Okay. She was almost like teaching those students how to do the programming, how to join the contest. Okay. Now he got into this problem. The problem is he worked out he basically say, if you use tree model, the tree model actually is quite sensitive. You may get overfitting. And if you use a multiple tree model, it will be better. Simply says, if you want to mine, you can use decision tree. You can use this one to mine. But he basically say, we use a random forest to do it. First, I probably want to ask here, how many people know random forest? Okay, we got almost half. Okay, that's great. The random forest actually is, I assume everybody knows decision tree. Okay, how many people do not know decision tree? It seems that everybody knows decision tree. Then that's probably much easier to handle. Random forest basically is kind of decision tree, but using not one tree, generally many trees. Okay, actually, you generate this tree even a little relaxed because you strictly follow decision tree induction method. You only generate one tree. Okay, but you relax. That means every time you try to pick up the best splitting point, you generate one tree. Okay, using supposedly information gain or Fisher score. Okay. But if you say, I just generate a bunch of reasonable trees, even randomly I generate these trees, but I do not generate one tree, I generate many trees. Okay, many tree means a forest, right? You get many trees, and then you are not going to use one tree to make a decision, or any of these one single tree to make decision. You run this multiple trees, or you can say run the whole forest in parallel, or in a parallel way. You don't need a parallel machine. You just say run them in parallel way. You get lots of different opinions, but you ensemble them. You take a vote, suppose. Then the highest vote one likely will be the right decision. It's more like suppose you take a tissue, you ask the doctors. Instead of you ask one doctor, you ask a bunch of them. Suppose you ask 15 doctors. They take a vote. Okay. Suppose each doctor is making a reasonable decision. They can be wrong. Okay. But you get 15 doctors, they take a vote, finally decide whether this patient is cancerous or not. You will be much more confident. Very likely you will make a right decision, right? So this is just the idea of random forest. Okay. Then you can see if you want to generate multiple trees, the disadvantage is the whole model size is rather big. You think about one tree, probably reasonably size, but you generate, say, 50 trees, it will be pretty big. Okay. So, and he was thinking about it, whether he can, using frequented discriminative mining, integrating with this random forest idea. Okay. He does not quite like the DDP mine because they still generate large patterns. That means they still generate lots of patterns. You have to make a decision. Okay. What he did, I can just use this example to show this whole flow graph to show what he did. Okay. What he did is this. He took this training data. Okay. Then he did some discriminant pattern generation. That means he analyzed a pattern, generated a bunch of trees, generated forests. Okay, that's why he called this one essentially is using random forest. But every one is a discriminant pattern generate this. After generating this, he's not going to use all those trees. What he did is he cut the tree, only take a branch. Okay. That means instead of thinking you have so many trees, you try to combine them to get a model. Okay. What he was doing is only take some, it could be leaf nodes or could be non-leaf nodes, only take some branch of the trees. You think about it, the tree has power, but the finer decision is on the leaf whether it's cancerous or not, right? And each branch has some power to do some discrimination, right? Each branch has some power. Okay. What he did is, instead of using all the trees, he cut the tree, got many branches. And what he do with this branch, he take this branch, it's almost like a redo using to construct a compressed model. That means he used the training data, try to get this branch, how important it is. You give this branch based on, it's more like doing regression on this branch. That means each branch is like a doctor. You think about this, or half of the doctor, you can think in that way. Each one gets some power, but you, based on training data, you can rank the doctors. You say which doctor is more trustable. You give higher weight. If this doctor is completely out of the hook, you even can give a negative one, right? So simply says you can take these half-grown branches. You think it's more like many of those partial doctors, but you combine them together, you based on the training, you give everybody different weights. Okay, using regression analysis, you give different weights to those each branch, then you construct a good model. That's his philosophy. And based on this philosophy, he's doing this testing, and he found his model, finally constructed this model, is very concise, okay, and also very high quality. Okay, so how concise, how high quality, I'm going to show you, but you probably can see the general philosophy is not that complicated, but it is very smart. Okay. The major advantage you will get is you only need very small number of such rules. How many you will need? He set a bound, say 20. Okay. He was thinking, if I get 20 rules to give doctors, doctor could be very pleased, because you just need, based on these 20 rules, to make a judgment. If the 20 rules are really good, you'll be happy. And he shows, even he just showed 20, he will get a very high quality one. Okay. That means what he's doing is finding discriminant patterns. Okay. What is discriminant pattern? Is a pattern with very high information gain. That means when you want to try to construct the branch, trying to construct those forests, try to find the quality ones. Which branch has a very high information gain, he will pick it up. He will get these top K patterns. The K is size of this pattern. That means how long this pattern is. Remember, Hong Chen already showed single one does not really work. You have to use length 2, 3, 4, right? He basically said he tried to find the size K, try to find the patterns, okay? And then he used this pattern, try to construct a rule, or you can think of these different patterns combined together is more like you think about several trees, you can get them together, okay? Then he will just use this, try to put this one into a regression model, and finally, based on this, you can construct a tree, right? So you can see what he did. The detailed algorithm is based on the training instance, okay? Then you can act the training, the detail, this X and Y. The interesting thing is the previous method, like Hong Chen and other people's methods, they all take this one as a categorical variable. It's more like you think about it, if you got, for example, smoke or not smoke, it's 1 or 0. Okay, you get a different gender, you get a 1 or 0 or something like this. You get all the binary or just categorical variable. His method allows the continuous variable. That means, for example, you say you take drug, what is dosage? You can get a continuous value, okay? Or you can body weight, and all these are continuous numbers, right? It can handle both numerical data and categorical data. How Hong Chen originally handled numerical data, she just did a binning. Okay, that means you originally you have a linear growth of the data. She partition them into, say, 5 or 10 bins. Okay, you based on certain cluster, you get this bin. Then you just treat them just like a, one categorical value, discrete value. And here, he actually allows the continuous value. And then construct this random forest. Okay. And the parameter he said is number of trees. He said like 20 trees. He has a information gain or loss function. He has a different depths. How deep the tree will grow. He will not let the tree grow very deep. And support means how many instances to support this case. Okay. And based on this, he actually, you can see, if you assume the number of trees is 100, the cltn pattern will be like 10,000. You will get a certain true case, but he actually used a very small number of rules. Okay, finally to get this. But the very detail, I probably will not get into very detail, but just show you the results. You probably will see how interesting it could be. Okay, he actually has two implementations of his algorithm. One is using forward selection using greedy method. Another is using lasso methods. I'm not going to get into details, but these are all popularly used in the classification method. But I'm going to show you the detail of what he got. Okay. The first interesting thing is he said this k is 20. It means I only allow my model generate 20 rules. That's a very small one. Like the doctor definitely would like to read it. Okay. And then you can see he actually compare with, typical random forest method and a DDP mine. He shows what his method can do. Okay. These different columns means different data sets. He still use those machine learning repository, these data sets, like Chess, Sonar, and many people are also using it. He shows random forest can get this high accuracy, and DDP mine can get this high accuracy. Okay. And then his method confine the size to 20. That means you only generate 20 rules. The model is much smaller than random forest, but he select this branch in a careful way. Okay. Then you can see he used the forward method, lasso method. You can see he generate every one is almost the highest one. Okay. Remember, this DDP mine already show that method is very powerful. You think about this method comparing with support vector machine with typical C4.5 is already much stronger. And here he basically shows his method here generally so small model size. That means only 20 rules. It's much smaller than DDP mine, but he basically get almost the highest one. Okay, not always the highest one, but you can see in many cases generate really high quality things. Okay. But the model size is very small. Okay. So that's very attractive because in practice, not only for medical doctors, they like to see rules. Many cases, if you are doing classification for stock market, for anything, okay, you want to see what's happening, not just want to see a black model. So just trust me, using support vector machine, using deep learning, you will do good. Okay, but sometimes you did it wrong. Okay, you cannot explain it. Here is you generate 20 rules, you get a very high quality rule, and you can explain it. Okay. That's the very nice feature you can see. This is the first time, based on my reading of so many classification papers, this is the first one can get so small model and and can consistently get so high classification accuracy. Okay. To that extent, I use this hour. I really want to recommend this one because you learn the course, you later in practice, no matter where you go, you do your research or you go to industry, you may think there in 2016 there's a method you may like to use. Okay, so that's the one I strongly recommend. Okay, and you may like to try. You probably can see the top K pattern. He used this forward and the lasso method. He shows the pattern he got. Actually, it's pretty, the accuracy is pretty high. It's almost, even you use a small number of patterns, it's already that high. Okay. Not to say, of course, you grow the pattern size, you can make it even higher, but that's pretty amazing, right? So that's a game. That's a classification game. Okay. So I just summarize. You probably can see why I finally, actually from Hong Chen to this one is almost 10 years. Okay, we keep silent for 10 years because we saw there are lots of people working on new methods. Okay, but you think about this pattern-based method, it does have some real good strengths. Okay. So he actually did a follow-up work, for example, for precision medicine, how to use these small number rules, and for different people, different patients, you have different structures, different features, how to integrate for individual patients, how to work out different classification model, or even survivor analysis or regression model. He has some follow-up studies, but since it's not published yet, I better not, lecture it. But this matter you can go a long way. Okay. So now I just show you a bunch of references. I probably should show this one because I sorted or based on the time or sorted alphabetically. So you probably can see this Shang's paper. Okay, DP class was published in Science Data Mining 2016. Actually, was not published yet because it's published in May. Okay, but it's on the web. You can download it. Okay, I hope later he can make it open source. Everybody can use it. Right? So before we finish the class, I should say we cited so many papers. Where to find them? I think you probably should know it because especially you want to prepare for the exam, right? You click this button. This button called Reference Papers for CS 512, Spring 2016. Okay. The paper, of course, the first two chapters we covered in the midterm already. You don't need to read them anymore. But the remaining papers, I usually mark red. You can see the marked red ones. Okay, but this one, the chapter 8, I did not cover. You don't have to worry about it. Okay, up to this chapter 7, say advanced classification, I only mark one really red. Okay, you can see the bold red is a main new paper in this class. Okay, that's a paper. You click this button, you will get it. You can click this button, you can see you will get a paper. Okay, I'll link to the right one. Okay, so I would suggest besides you read the slides because some part is too brief. Okay, you try to understand it, you need to read the papers. That's why I put those papers. It's very easy to fetch. Okay, nowadays it's much doing graduate study is much easier because in the early days you try to fight for proceedings, the paper proceeding. You go to the library. You keep just using the copy machines. You just insert coins to get a page by page. It takes you a long time. But nowadays, you just sit in your office, you just click a button, you get everything, right? So that's much different, but it's much more pleasant. You can see that's the chapter 7 classification. You just need to read one paper, okay? Then for others, for example, for the previous one, mining spatial temporal social media data. Unfortunately, I cover more red ones you may want to read, but you can go over those papers. I think the major two red ones, one is Zhi Junyin's paper, probabilistic model for latent pattern, and another one is Zhi Junyin's paper. And I also lecture Chao Zhang's paper on splitter. I think these several papers you may like to find. Just click the button, you'll get it. Actually, I think the Chao Zhang's newest paper, this one, no, not this one. I think the very newest paper where it is. This one. This is GeoBurst. Is published in 2016. It just accepted. This one is not a final version. You go to my publication site, you will not be able to get it. You go to this site because we haven't finalized it. We do not put it over there. Okay. But this one is a submitted version. Is good enough for you to read it and digest it. Okay. So now we finish everything. Okay. I still have some time. One thing we want to do is a course evaluation, but I leave only 10 or 15 minutes for you to do course evaluation. But I want to see, based on what we cover here, the first thing is I want to see what the major things you think you have learned and you really want to raise questions about a midterm exam. I can answer now. Another thing is you think based on your research, or many of you are PhD students, based on your research, what are things covered here you think is really interesting and useful, or what other things you would like to be covered? Okay, I would like to see or get a little discussion. So want to see, what you really like to see. Of course, one thing I probably should claim beforehand is this one is advanced data mining class. It's not an advanced machine learning class. There are some very trendy machine learning topics, for example, like deep learning, probability graphic model, all those things I did not cover. Okay, I assume they will be covered by a machine learning class. So we cover things is more on the things we think is very interesting for you to study, like how to get networks, how to get the text, how to get those stream data, how to get the classification and the spatial temporal, those things, including data streams. Anybody would like to get a little discussion before we hand in the course evaluation? You can ask questions if you want to know more things about a midterm exam. Practice midterm. I think that's a good question. I think I can probably publish some previous year's exam, but it will be very different. You can see. We cover very different things. If I publish, say, 2 years ago, the exam I probably can give you, I can publish it, but you see it's completely different course almost, because we discuss advanced clustering, outlier analysis, all those different things. Whether it's useful or not, I'm not quite sure, but we can publish it. That's a good suggestion. Yeah. So any other questions? So what will be on your wish list? For example, you took this course. Maybe your wish list may help the future students the next year or a year later, right? Do you like the research project? I do not know. Some people may feel it's a little torture, but some people enjoy it. Yes? Data mining for images. Okay. Yeah, actually, data mining for image in many cases should be covered, or most of them should be covered in the pattern analysis. There's a conference called CVPR, Computer Vision and the Pattern Analysis, Pattern Recognition. I think we do have such courses in our department. In principle, they should cover this. Because image analysis, you can say data mining as well, right? Yes. Okay. Yeah, okay. So the question is the open source of the code. Okay. Uh, those code are all in GitHub. Okay. But the best one, the best suggestion this, okay, because of the GitHub, the students, they implement this, sometimes they change the address or change versions. The best way is go to the first author's website, because I ask them to publish it. I ask them to put on the website. In principle, they should go give us a pointer in Illumine, but I'm not quite sure whether they really do this. Okay, let me try it. We have this one, Illinois Data Mining Group. There are lots of code there. But since recently most of the code are on GitHub, so the students start putting on GitHub instead of putting on Illumine. Okay. I think there are quite a bunch of things here, but most of things were before 2015, I think. Actually, I discussed many things that are after 2015. So if you look at this, this is a little too old for you. Okay. Of course, I will try to ask my group, the students, try to build up some entries and link to their GitHub address. That's probably more systematic. Yeah, that's a good question. You go down to their website, you will be able to find it. But on the other hand, I'm going to build this one probably within a few days. Okay. Other questions? Okay. Yeah, hopefully if you like this course, you learn something. Maybe you learn too much. Okay, I do not know. But just, you know, you hopefully those things later will be useful. Because at least one of the classmates here in the previous many years ago, he went to Google, came back to recruit students. He told me, he said these two courses, 4.5 and 5.12, he took both, are really useful because in Google for 8 years, he said except some Hadoop stuff and some deep learning stuff, almost everything he learned from this course is used in Google. Okay, so that comfort me a little because I fear, you know, it could be useful if Google people say it's useful. Okay. So now I probably should distribute this so you can have the course. Usually this sheet, because in the past many years when I distributed, the class is quite empty. Okay. So only a few people give me the feedback. But thanks to one student who raised a question, said we should have a course attendance sheet. So now we get a pretty full class. So I need one student to volunteer to bring this one to the department, like you can bring to Donna, to the secretary. Okay. Okay. So Stephen, I need another one who need also. I think Kuyan, you will bring this. Okay. So what about this? I have to leave, but I need one student probably or two to distribute all these, okay, and then collect them, okay. So you probably can distribute this to all the different group, and another group probably distribute this. I need to give Stephen the whole package here. And you need to fill up using pencils or black ink ones. So I need anybody to distribute this and then collect it. Okay. Since you have a little more time, you may like to write some comments there. Okay. So that will help.